As promised, we'll just do a quick review of a solution for the practice test we did this week, practice test for test 2, right? And actually, this is the solution I did sitting in the room with you as you were working on the practice test. So I'm not going to post it. We'll just quickly walk through it. I won't drag this out too long, but I'm going to try to share a couple of extra value-added bits and pieces as we do so. Okay, getting back to the practice test. So the whole idea, we're using our company database again, and each department has a field department budget. That's the budgeted amount that they have to pay all of the employees in the department, right? And that's what we're going to deal with is, hey, what is the current cost to the department for all the employee salaries, and do we have room to hire anybody new, things like that, right? So we'll start with question 1, a scalar function, okay, that receives a department code, parameter as input, returns a total of all salaries paid to employees in that department, okay? And of course, if the total comes out to null, then we want to make sure we return a 0. We don't want any null values to mess up further calculations down the chain, so to speak. All right, so coming here, I've got a bit of a start. I didn't want to do it totally from scratch, but we'll just kind of walk through it fairly quickly. So here's my UDF, of course, user-defined function, salaries paid as per the instructions. Notice the parameter. We're passing in the department code as instructed. Now, the data type, I've mentioned before that there will be marks on the test for choosing appropriate data types for your parameters, for your variables, etc., right? So the department code, well, my advice to you already was come and look in the actual design of the tables and see what data types are being used. So in the department table or department code is a char4. So that naturally should be the data type for our parameter here when we pass in a department code. Now, when it comes to what we're going to return, remember, think about this. What we're going to do here, come to employee, and the data type we have to be concerned about with initially here is emp salaries data type, decimal 9,2. Now, during the practice test, walking around the room, I noticed some students immediately went to, maybe we've just done so much practice with integers, they started to use the integer data type. Well, that's not going to be very good, right? Because you're talking about actual currency values here, like how many dollars and cents people get paid. So if you just ignore those pennies, that's not going to give you very accurate results. So integers aren't good. Truth is, decimal is actually kind of like a fancy integer, really, isn't it? Because remember how decimal works. The first parameter we pass is the precision, comma, then the scale. The precision is actually how many digits in the number we're going to maintain. And then the scale is how many of those digits are behind a decimal point, right? So if you have a decimal 9,0, well, that's basically like a 9-digit integer, right? So anyway, just kind of food for thought there. So with the decimal 9,2, though, the trouble is if we add up a large amount of records, and imagine that all of our employees make a lot of money, maybe they're right up near the top of the value that could be supported by that data type, decimal 9,2. Well, it's easy to imagine then if you're adding up a whole bunch of salaries in that range, the end result might not fit in a decimal 9,2, right? So we might want to go with something bigger. Now, in fact, we should go with something bigger, right? Just in case. We would probably get away with it. We certainly would with the sample data we have in our database, but that's not the correct answer itself. The question is then, how big do we go? Well, again, look at the department and notice its data type is decimal 10,2. So if you went with that, I would accept that answer, right? That means that if we add up a whole bunch of salaries that are smaller or small enough to fit in a decimal 9,2, then we probably would get away with a decimal 10,2, right? And I would accept that answer. However, I'm going to share with you my thought on that and the reasons for it. I would actually go with something like this, decimal 19,2. Wow, that is huge, you say. Well, you're right, okay? But we might need a larger than the data type of the emp salary. And there's a reason why, and I'll talk more about that in a second here. Okay, why I might even go up to something this big. All right? So let's go on in the next thing. So we have to prepare a variable, right? So that variable naturally will match the data type that I've defined as the data type I'm returning from my scalar function. So I'm going to call it at total salaries, and it as well will be decimal 19,2. So I've got some notes there. Going above a precision of 9 will up the storage requirement. I don't have it here in my notes, but I'll include it later on. Basically, anything from a precision of 1 up to 9 takes the same amount of storage for each value. It uses 5, count them, 5 bytes of storage for every decimal 9,2 down to even a 1, right? That's precision of 1. But when you go above a precision of 9, you jump. And all values from a precision of 9 right up to precision 19 use the same amount of storage, 9 bytes of storage. So a general thought that many developers put into practice is that, hey, I'm using the same amount of storage no matter whether it's 10,2 or 19,2, right? So I might as well go with the biggest value just in case I end up having a huge number I do need to store there. It's the same cost in terms of the storage all the way through those ranges of precisions. So I might as well go with the maximum one, okay? So decimal 10,2, sure, that would work and I'd give you full marks. But, why not just follow the path of common sense and say, hey, there's no extra cost in going to a bigger decimal here, so I might as well go up as big as 19,2 because they all use the same. All right. Okay. Then we have to actually do the calculation. For that, some students, again, walking around the room, I noticed used naturally a group by clause, thinking that, hey, I have to group it by department. But you know what? It is true. We want to use the sum, the aggregate function, to sum or total up all the salaries. But our where clause takes care of that. Okay, because we're filtering for the one and only department we want to include records from, okay, our department code takes care of that in our where clause. We don't need a group by as well, okay, because that's actually handled by our filter, our where itself. But of course, it's from the employee. We're just going to sum up all the salaries and assign that in our select to the actual variable we created earlier, our total salaries. So naturally, all we do is we return total salaries. That's it. And that should work, okay? So I'll execute this code to actually then create my function. Now to test the function, I've got a few different test cases here just for the fun of it. Let me just show you the results. Okay, so for information systems, yep, that looks like a reasonable value. Total salaries for marketing, 60,000. And look at that. The personnel department is 0, okay? They all work for free. Yeah, anyway, you get the idea. All right, so the next, coming back to the instructions, the next thing we were asked to do in number 2, create a view that displays the following. Okay, from the department table, the code, the name, and the budget. And then we want to see the department's total salaries, says using our function that we just created. And finally, a calculation for the amount of the budget remaining, right? Okay, all right, fair enough. So what do we end up with? Something that looks like this, okay? Notice that we do not need a join. Okay, some students immediately join department and employee together, but truth is our function, okay, our function looks after all the requirements that we have here, right? So we don't need to actually join the employee table in because our function goes to the employee table and does what we need it to do. It adds up the cost of all the salaries for the employees in the specified department, right? So that's good enough. Of course, using an alias, otherwise it would just come out without a good column heading as total salaries as per the screenshots in the instructions themselves. Now, you might think that, hey, I could just take this total salaries, right, and use it in the next expression, but I can't, right? Try it if you want. You'll see it doesn't work. So I'll have to do the calculation budget minus and call my function once more here. And that's the way we go in a view, right, as remaining from department. Let's just create the view. And then to test it, okay, well, that's a simple select, okay, from our view, and away we go. So let's just see, and sure enough, yep, we can confirm that we're getting the exact same output as the screenshot provided here, so we can see all the values are calculating correctly. Whew. All right, we're doing okay so far. Now the next one is our trigger. Okay. So it is a after insert. That's right in the instructions. Let me go back to the instructions for a second. Create an insert trigger on the employee table to make sure that when a new employee is added, we aren't going over budget, basically, for the department. Okay, when we consider their salary added in, we don't want to go over budget. If we did, we want to show a feedback message and then roll the transaction back, right? It says here the trigger should use our UDF salaries paid function as well. All right, so coming back here again. Okay, just to emphasize on what table. Well, the instructions made it very clear. It's on the employee table after insert, right? So the first thing we're going to have to do is find out what the department is that the new employee has been added into, right? So to do that, I will make a variable to store it because I'm going to need to know this later on. And again, the data type matches the data type of department code in the department table, right? Now, where do we get that? Of course we get it. We're in an insert trigger. So it's the inserted temporary table has the copy of the record that was just inserted. So that's where we go then. From that table, we find out the department code, store it in our local variable here that we just declared. Now, we needed to find out the budget for the department. That would be our next step, right? So I can do a query here. I'll make a variable. And again, I'm going to use, why not 19.2? Well, I could, okay? That would not be wrong. However, you could argue that, well, really, I am storing a value. I'm not even manipulating it. I'm just storing a value from the department table, okay? The budget as stored there. So again, looking at the department table, the budget is a decimal 10,2. I'm just storing the value from there. So it's perfectly reasonable to use decimal 10,2 in this case. Would I be wrong to use the 19,2? No. But I would just follow the general guideline I've emphasized multiple times in the past, use the matching value to whatever the table design or table schema requires, right? So there we go. So I'll declare my department budget, decimal 10,2, go get the value from the department table using the code, which we got from the inserted table up above, to filter for the one department that we're after. Are we over budget? Well, that's the last thing to really think about here, right? Okay, so if using our function, again, make sure we use DBO dot, okay, the schema of the function when we call it, salaries paid for the department. If it's greater than the budget, then we're over. Now, I'll share one thing with you. Walking around the room again as people were working on the practice test, I noticed a couple people making just a little mistake. When our function executes, our salaries paid function here, remember when this is happening. This is a after insert trigger. The record is already being inserted into the employee table. So our salaries paid function, the total it returns includes the salary of the employee that we are inserting here, that we technically have just inserted, right? So some students were using the function, calculate salaries paid for the department, and they're doing plus and adding. Okay, so up here, when they queried the inserted table, they made a second variable to store the employee's salary, so they knew how much the salary was of the employee being inserted. And they actually came down here and added it in at this spot in the actual query, right? With a plus and so on, right? No, we don't want to do that because it's already there, okay? Truth is, though, because of the test that is specified in the instructions, okay, it just used a value that definitely put us over budget. Well, the trigger would work. It would roll back, but it would roll back for the wrong reason, right? It would roll back because we've actually doubled. We've taken that salary and added it twice, essentially, once from the function and once by manually adding it as well. So that would be a mistake that would definitely lose you marks on the actual test. So point is, remember, the after trigger, okay, the record is already being inserted, deleted, updated, whatever, when you go to manage it in code. All right. So our salaries paid function tells us everything we need to know. We compare that to the budget. If it's greater than, we're over budget, and we'll just, print our message as instructed and roll back the transaction. So let me come up here. We'll create our trigger. There we go. All right, now for the testing, I don't have any reveal going on here. What I suggest is before the testing, I'm just going to bring up the results of our view. Okay, see that it still matches everything that we expected. Very good. So to test the trigger now, let me point out something here. In the instructions, we gave you a test case to use, right? And the salary was $120,000. Well, look right above here. Marketing, how much is remaining? $110,000. So adding employee with a salary of $120 should definitely cause the trigger to roll back because we've gone over budget, right? And sure, that is a valid test in a sense, right? However, we haven't talked about it yet, but we're soon going to be introducing a whole segment on unit testing, creating tests of all of our code, bite-sized units at a time. And one of the concepts that we talk about when we get to unit testing is boundary testing. In a nutshell, what boundary testing does, and this isn't required, I didn't expect you to know this. I'm just sharing some value add here in our review of the test. Boundary testing is done when there's a change of behavior at a boundary, right? So in other words, a little bit above or below or, a value, if there's a change of behavior, then we want to zero in as close as possible to where that boundary is and make sure that the change of behavior happens at the appropriate boundary. So again, if I bring up this, see we have $110,000 remaining in the marketing department's budget, right? So I am going to choose, instead of doing, or maybe in addition to doing the test specified in the instructions, I'm going to take that $100,000 and go as close as possible, but over that limit by adding 1 penny, right? So this should cause the trigger to roll back the transaction because I'm going 1 penny over budget, right? Now let's just wax poetical here for a second. How close is close enough, right, to the boundary for reasonable testing? Well, in this case, 1 penny is the perfect amount, right? Because we are talking currency values here, okay? If we were in more of a floating point situation, then our rule of thumb is, basically 1/10, right? So if I could go to 1/10 of a penny, that would be a very reasonable thing to do, but I can't because I'm dealing with literal dollars and cents in this case. So, 1 penny is the perfect amount. So this should cause the trigger to run, right? And I'm going to go ahead and try this out. And sure enough, there we go. I got our message we asked for, canceled. Employee salary, put the total for the department over budget. Okay, and we actually rolled it back. How do I know we rolled it back? Well, it's just one of the many ways I could check. I could check the employee table, make sure the record's not there. But here I can see that, no, our view shows us that, no, we still have the full remaining amount for the marketing department. It has not changed, so definitely we did not affect that. Our record was rolled back, and we did not insert the record. So to test the other side of our boundary, okay, I'm going to go back to the allowed remaining amount, the $110,000, and we'll try inserting using that as the salary for Jackson Jones here, our consultant. And this one should work. This should be allowed to insert. So we execute and bada bing, look at that, 1 row affected. Okay. So again, this is above and beyond what I expected, but I thought I'd share with you this concept of boundary testing, right? So if I check my view one more time here, look at that. The remaining budget in the marketing department is now 0, right? Because our employees, the total salaries match the department budget, and we're right back to having nothing left for any new employees. But a good idea when you're doing a test like this, delete the test record that we put in. So we put the data back the way it was, okay? As a general rule, because it's not always the case, but as a general rule, when you're doing a test script, you want to put the data back the way it was as much as you possibly can. So I'm going to delete the record. Sure, I could pull some tricks out my sleeve and find out the ID of the new employee and use that. But you know what? This is going to do the job. I'm going to be able to identify by matching all the fields here that I inserted. That'll identify the record, thereby removing my test record, and I'm right back to having my full remaining amount the way it originally was because that employee has been deleted. All right, so that finishes our discussion. Okay, so to highlight again, we've seen the required code. There could be other ways to do it. For example, in the trigger, walking around the room again, I saw at least one student doing this. Instead of using the function this way, what they did is instead of selecting from department, they selected from our view, right? And they pulled out, okay, not just the budget, but the remaining amount and so on and so forth, and used that in logic. And that avoided them calling the function again, right? And then that was a kind of a clever approach, I thought. I hadn't thought of doing that, but yeah, that would be a valid approach. And my rule of thumb here at this stage of learning computer programming is if you find an alternate way and it works and is logical, then that should be acceptable. And I would accept that approach on the test as well. Technically, you didn't follow the instructions to the letter because your trigger didn't actually call the function, but you did call it by using the view. So I would accept that. All right. End of my preaching for today. I'll leave it at that. Hope you had fun and learned a couple extra things about boundary testing and the fact that, you know, to use 9 bytes for anything 10 and up to 19 and so on and so forth. So you can consider that as well.